So far, we have been considering proper fractions, a case whereby the degree of the algebraic expression at the numerator is less than that of the expression at the denominator. So now, what if we have improper fractions? How can we decompose such fraction? Well, here's what you need to know. Consider 3 over 2. It's no more in news that 3 over 2 is an example of improper fraction. To reduce this fraction, we are going to turn it into mixed number. In how many different ways can 2 go in 3? That's 1 different ways. Then we just have the remainder at the top. Then we are going to put this back at the bottom. Each of this number has a particular or genuine name. The one standing alone, this one, is known as the quotient. The one at the top is known as the remainder, while this two is known as the divisor. The initial 3 also has a particular name which we called the dividend. So why do you need to know this? Because we'll be using this knowledge to decompose improper fraction. To decompose improper fraction, we need to first divide these fractions by determining the quotient of that fraction, the remainder of that fraction, and the divisor which will be given in all cases. Now, one more thing you need to be familiar with is that the whole number 1 over 2, which is the mixed number, can be rewrite or re-expressed as 1 plus 1 over 2, where this is the quotient, this is the remainder, and this is the factor. So this will be our main goal. Our main goal is to express the improper fraction that we are to partialize or decompose into a situation whereby we will be having the quotient to be adding the remainder divided by the divisor. So at the end of the day, this will become a proper fraction that we will be able to partialize. So let's consider some examples in order to analyze what we are saying in essence. Example 1. Consider x to the power of 3 plus 2x squared minus 2x plus 2 to be divided by x squared plus 2x minus 3. Why is this an improper fraction? And what are we expected to do? The first thing you must consider doing is to observe the degree of the highest term of the highest degree at the numerator. That's 3. Now, what is the highest degree at the denominator? That's 2. So therefore, we are having a top heavy. What we are having here is bigger than what we are having at the denominator. So therefore, we are having improper fractions. So to decompose this fraction, we need to first divide the fraction. And to divide it, we'll be using the idea of long division, which is simply written for short as DMS. You divide one term, you multiply all 2, and you subtract all 2. How does it work? Let's put it in practice. So first, you need the table. Outside the table, you have to write or insert your divisor. Don't forget, this is known as divisor. This is known as divided. Okay, so the divisor is x squared plus 2x minus 3. Inside the table, insert your divided x cubed plus 2x squared minus 2x plus 2. Having done that, you can proceed on this. Divide, multiply, or subtract. So x cubed divided by x squared, the result will simply be x. Now you have to multiply all 3. You have to multiply this by each of this term you are having outside. So x times x squared, that results in x cubed. X times 2x squared, that results in positive 2x squared. My bad, I mentioned 2x squared. Then write this 2x. Then x times negative 3, that's negative 3x. Now, one term is left here, but no more term is left here. When this occur or take place, you can just put the 0. So now we can subtract. We are subtracting the lower part from the upper part. So x cubed minus x cubed cancels out. 2x squared minus 2x squared cancels out. Now, what will be negative 2x minus negative 3x? It turns out that this negative will affect each other and makes it to become positive. Then we have negative 2x plus 3x, which will eventually be x. So we are left with x. Now what about plus 2 minus 0? That's just positive 2. Perfect. Now, since the degree of the variable you are having left over is 1, and 1 is less than the degree of the divisor, then you have to stop at this point and consider whatever you are left over here as your quotient. And that you are left over here as your remainder. Please be very, very careful. Before you can stop the long division, make sure that what you are eventually having here is smaller than what you are having right here. Typically, the degree of that variable. The degree of the variable here is 1, and the degree of the variable here is 2, which makes it to be less. And therefore, we have to stop. Assuming it is 2, you have to repeat it one more time. Assuming it is 3, repeat it one more time. But once it is less than the divisor's degree, then you have to stop. Perfect. So now quotient will be what we are having right here, which is x. The remainder will be what you have left over here, x plus 2. And the divisor is still what it is. The divisor equals x squared plus 2x minus 3. So which means this compound fraction, by the time we reduce it a little bit, will eventually become or be expressed as x plus the remainder x plus 2 divided by x squared plus 2x minus 3. And that's how it works. Now you can see that we can now partialize this one as it has become a proper fraction. And that's just the basic idea behind problems involving improper fraction, typically partializing improper fraction. So first, you have to reduce that fraction to the extent that you'll be able to figure out the quotient, likewise the proper fraction part. So you can be able to partialize the proper fraction part. So now our main goal is to partialize this part. So before we partialize it, we need to factorize the denominator completely. If it can be factorized, then we use partialization using quadratic factor. Well, I think what we are having right here is factorizable. So what two number multiply to negative 3x squared and add up to 2x? So what should that be? That will be negative x, typically negative 1x, and positive 3x. When we have this up, we have 2x. When we multiply them, we have negative 3x squared. Perfect. So now, what we are going to do is to replace the middle term with these two terms. So therefore, it can become x plus 2 all divided by, let's ignore the quotient for now. We are going to bring it back when we want to write our final solution. So x plus 2 divided by x squared plus 3x minus x and minus 3. So now we can take out some of the common factors. That will be x plus 2 all divided by what is common right here, that's x. So bringing x out, I have x plus 3 left over. And for this term, negative 1 is common. Bringing negative 1 outside, I'm left over with x plus 3. So now we can take out the GCF, the greatest common factor. So I'm going to get rid of this for now. But don't forget, we still have the quotient to be x. So now we have x plus 2 all divided by x minus 1, because we need to combine the GCF, then x plus 3. Perfect. So now, how can we decompose this fraction at this point? It turns out that it's consisting of linear factors. So that will be a divided by x minus 1, then plus b divided by x plus 3. So we can multiply all through by the denominator, which is the product of x minus 1 and that of x plus 3. So for the green color, the whole term will cancel out at the left hand side, and left over will be x plus 2. And this will be equals. For the yellow color, x minus 1 will get rid of each other, and left over is a times x plus 3. Let me write that properly. And for the blue color, x plus 3 cancels out, and left over is just b times x plus 1 or x minus 1. So now we can determine the value of a and b respectively. First, let's determine the value of b. To solve for b, we need to make this to be 0. And for it to be 0, x plus 3 has to be 0. And x has to be equals to negative 3. So plugging in negative 3 as x in this whole equation, we can have negative 3 plus 2 plus 2, then equals to a in a bracket of negative 3 plus 3, then plus b in a bracket of negative 3, negative 1. So negative 3 plus 2 is negative 1 equals, this becomes 0, so I ignore that. Then I have negative 4b. Because this is negative 4 multiplied by b, that's negative 4b. So dividing all through by negative 4, eventually we got b to be equals to 1 by 4. This negative will get rid of each other, and we are left over with 1 by 4. Having gotten that, we can determine the value of a as well. To determine the value of a, we need to make the whole term that is associated with b to be 0. Now for it to be 0, x minus 1 has to be equals to 0 too, and x has to be equals to 1. So substituting 1 as x in this whole equation, then we have 1 plus 2 equals to a in a bracket of 1 plus 3, then plus b in a bracket of 1 minus 1. Now you can see that this becomes 0 at the end of the day. Then we have 3 when we had 1 plus 2 to be equals to 4a. And dividing 2 by 4, we got a as well to be equals to 3 over 4. So having gotten that, we can now write our final answers. So therefore, the fraction x plus 2 divided by x minus 1 multiplied by x plus 3 can be split or decomposed into 3 over 4 divided by x minus 1, then plus 1 over 4 divided by x plus 3. Perfect. So now let's bring the 4 to the bottom, respectively, okay, because that's like a fraction dividing a whole number. So that will be 3 divided by 4 multiplied by x minus 1 plus 1 divided by 4 multiplied by x plus 3. So some of you might be wondering how that is possible. What I did was that I changed the 3 over 4. Then this division, this long one, I changed it to the regular. Then I have x minus 1. I have x minus 1. So now we can use the concept of keep, change, and flip. You keep the first fraction, you change the sign to product, then you flip this one. It's like having it to be divided by 1 before. So once you flip it, the 1 comes up and the x minus 1 comes out. If you multiply this, you will eventually have this back. And I played the same thing for this one as well. And that is how I end up having that. Perfect. So now I can write the finest answer, the final and final answer. Because this is not really our final answer, this is just like the decomposition of the x plus 2. Now for the decomposition for this whole fraction, we need to attach the quotient. The quotient is x, don't forget, plus this one. But this one has been turned to this one. So now we can write it as plus 3 all divided by 4 in the bracket of x minus 1 plus 1 divided by 4 in the bracket of x plus 3. And that will be our final answer. Hopefully you understand that. Let's consider some more other examples. Consider x cubed minus x squared minus 4x plus 1 all divided by x squared minus 4. Feel free to pause the video and make use of what we have discussed so far to decompose this improper fraction. First, we need to re-express this whole fraction in the form of the quotient plus the remainder divided by the divisor. The divisor is already given as x squared minus 4. Our main goal is to determine the quotient and the remainder. And to determine this, we need to divide the fraction using the long division process. So let's draw the table as usual. So outside the table is meant for the divisor, and inside the table is meant for the divided x cubed minus x squared minus 4x plus 1. So let's divide x cubed divided by x squared, that's simply x. Then we multiply also x times x squared, that's x cubed. X times negative 4, that's negative 4x. So no other term. So we need to put 0 for that. So we're putting 0 for this. Now this negative 4x should be below its like terms. So let's shift it a little bit. Okay. So I'm shifting it a little bit. Perfect. So don't forget, positive sign should be here. If you use negative sign, it can't change anything. Now, what about x squared? Negative x squared, there's no term there. Then just assume it is 0x squared. Okay, plus 0x squared. It's just as if you haven't changed the whole term you're having here. It's just that you are trying to change the visual illustration just to make things work out for you. So now we subtract. X cubed cancels x cubed. Negative x squared minus positive 0x squared. That's indeed negative x squared. Now negative 4x minus negative 4x. That should be 0. Perfect. That's 0. So I'm not writing that because I don't need it anymore. Then positive 1 minus positive 0. That's just positive 1. Okay, that's positive 1. That's positive 1. Perfect. Now, the first question you ask yourself at this point is that the degree of what you are having left, is it more or equal to the degree of the divisor? If it is, then repeat the division process one more time and still continue to do this. But if the degree of this you are having left here is less than the degree of the divisor, then please just stop at that point. Consider this as your remainder, then this as your quotient. But now we can repeat it because they are equal. X squared divided by x, that's negative 1. Now multiply 1 times x squared, that's x squared. Then 1 times negative 1 times negative 4, that's positive 4. This is negative 1 times x squared, so it should be negative x squared. Now we can subtract. We have multiplied, next is to subtract. Negative x squared minus negative x squared, that should be indeed negative x squared plus x squared, and which cancels each other. Now positive 1 minus positive 4, that will be negative 3. So eventually the remainder is negative 3. So now this is our remainder. The quotient is equals to x minus 1. The remainder is indeed equals to negative 3, and the divisor is equals to x squared minus 4 as supposed. Perfect. Now we can proceed on partializing this compound improper fraction. Since we know that this fraction can now be written as x minus 1 plus then the remainder, which is minus 3. Let me put that in bracket and we open this later. Minus 3 all divided by the divisor, which is x squared plus 2. We don't need that anymore. Let me remove it. Okay, divided by the divisor, which is x squared minus 4. So let's expand the bracket. That will be x plus 1 minus 3 divided by x squared minus 4. Perfect. So now let's focus on this. This has become a proper fraction that we can actually partialize. Then you just leave the quotient like that. You will bring it back when you want to write the final answer. ignore the negative for now too. Let's skip it. Let's just focus on 3 divided by x squared minus 4. However, you can take the negative along, but just to make things work out very fine for you, just leave it and you bring it back later. Anyhow. So now I have 3 divided by x squared minus 4. Let me factorize the denominator completely. It's a difference of 2 squares because it can be written as 3 divided by x squared minus 2 squared. And what says the difference of 2 squared? A squared minus b squared can be written as a minus b, a plus b. Perfect. So that's exactly what I'm going to do. So this becomes 3 divided by x minus 2, x plus 2. Now it has been factorized completely. Now we can partialize. Let me bring it a little bit to the side. So since it is a fraction with linear factor, then the partialization form will become a divided by x minus 2 plus b divided by x plus 2. So let's multiply all through by x minus 2, x plus 2. So it turns out that for the green color, the whole terms will cancel out. And for the red color, x minus 2 will cancel as x minus 2. And left over is x plus 2. So this is 3 equals a multiplied by x plus 2. Then for the blue color, x plus 2 cancels out. And left over is x minus 2 plus b multiplied by x minus 2. So now let's set this whole term right here to be equal to 0. And to make it 0, x plus 2 has to be 0. And x has to be equals to minus 2. Plugging in x equals minus 2 in this whole equation, we have 3 equals a in the bracket of minus 2 plus 2, then plus b in the bracket of minus 2 minus 2. And that will eventually make this to be 0. And left over is 3 equals minus 2 minus 2 is minus 4b. Dividing 3 by minus 4, then b equals minus 3 over 4. Keep that somewhere. Perfect. Now we can solve for the value of a. To solve for a, we need to make this whole term right here to be 0. And for it to be 0, x minus 2 has to be 0, and x has to be equal to 2. Then substituting 2 as x in that equation, we have a 3 equals a in the bracket of 2 plus 2 plus b in the bracket of 2 minus 2. You can see this whole term becomes 0, and we have 3 equals 4a. And dividing 2 by 4, a equals 3 over 4. So b is the opposite of a in terms of sign. So that will be 3 over 4. And I said b is the negative of a. Perfect. So we don't need that anymore. Let me get it with you. So therefore, the partialization form of negative 3, okay, we're using only 3, of 3 divided by x minus 2 and x plus 2 is written as the value of a, which is 3 over 4, all divided by x minus 2 plus the value of b, which is negative 3 over 4, all divided by x plus 2. So now, just like before, we can bring those 4's all the way down. Also, this positive sign can be affected by this negative and turn it to negative. Okay, so we have 3 all divided by 4 in the bracket of x minus 2, then minus 3 divided by 4 in the bracket of x plus 2. Should this be our final answer? No. Don't forget x plus 1 and also the minus. So let's bring them back to write our final answer. So final answer in this case, this fraction can now become this. So that will be x minus 1, then minus, let's put that in bracket because it will be affecting the o. 3 divided by 4 in the bracket of x minus 2, then minus 3 divided by 4 in the bracket of x plus 2. So by the time we expand the bracket, we will eventually see that final answer will be x minus 1 minus 3 divided by 4 in the bracket of x minus 2. Or we can see that, then plus 3 divided by 4 in the bracket of x plus 2. And that will be our final answer. Hopefully you can figure that out. Now, let's consider one more example for easy understanding. By the way, if you haven't subscribed to my channel, please do well to subscribe to my channel. Also, if you're enjoying the video, kindly give it a thumbs up so YouTube can recommend it to many audience out there. Now consider x to the power of 4 minus 4x cubed, then plus 9x squared minus 17x plus 12, all divided by x cubed minus 4x squared, then plus 4x. How can we partialize this compound improper fraction? Well, just like before, our first main goal is to re-express the fraction into the form quotient plus remainder divided by the divisor. So what will be the quotient? Likewise the remainder. Who knows? Well, let's see. We already know the divisor. So just like before, our long division table. So inside or outside, I have x cubed minus 4x squared plus 4x. Then inside, I have x to the power of 4 minus 4x cubed, then plus 9x squared, then minus 17x plus 12. Perfect. So now we can begin. Divide x to the power of 4 all by x to the power of 3. That will be x. Then you multiply all two. X times x to the power of 3, that's x to the power of 4. X times negative 4x squared, that's negative 4x cubed. Then x times positive 4x, that's positive 4x squared. No more term left, we can put 0 plus 0. Now we subtract. This cancels out eventually. This also cancels out because negative 4x cubed minus negative 4x cubed becomes negative 4x cubed plus negative, no, plus 4x cubed. And they eventually get rid of each other. Perfect. Now, what about 9x squared minus 4x squared? That would be 5x squared. Then negative 17x minus 0, that's negative 17x. Then plus 12 minus 0, that's plus 12. Now the next main goal. The next main goal is to determine or observe or investigate the degree of the remainder and that of the divisor. Now the degree of the divisor is more than that of the remainder. So definitely this is our remainder. This is our quotient. This is our divisor. Perfect. So eventually we can rewrite this whole bigger fraction in this form. Okay, let me find a way. Let me write it here. Quotient is equals to x. Remainder is equal to x, 5x squared minus 17x plus 12. While the divisor is equals to x squared minus 4x squared plus 4x. Perfect. So now we can get it of the table. Then we have x plus remainder, which is 5x squared minus 17x plus 12, all divided by the divisor, which is x squared. Okay, that will be x cubed minus 4x squared plus 4x. This is x cubed, keep in mind. Good. Now, we can partialize this proper fraction. To partialize it, we need to factorize the denominator completely. So let's see if it is factorizable. 5x squared minus 17x plus 12. Since x is associated with all terms, let me first of all take x as the common factor. So I have x in the bracket of x squared, then taking x out, minus 4x, taking x, plus 4, plus 4. So now, what else can we do? Is this quadratic expression, is it factorizable or not? Let's see. What two numbers multiply to 4x squared and add up to negative 4x? Well, let's find out the prime factorization of 4. Or let's just say two numbers that multiply into 4. We have 2 times 2. With this work, let's associate x with it. 2x times 2x is 4x squared. Perfect. But if we add them together, it will give us negative 4. So we can associate negative sign with them. So negative 2x times negative 2x is positive 4x squared. And their sum will be negative 4x. So we are using negative 2x and negative 2x. So that will be a perfect square trinomial. It should become 5x squared minus 17x plus 12, all divided by x in the bracket of x squared minus 2x plus 4. So this trinomial is actually a perfect square. Then we can have it as 5x squared minus 17x plus 12, then divided by x in the bracket of, taking x out, that would be x in the bracket of x minus 2. Then minus 2 here, that's minus 2 in the bracket of x minus 2. Okay, perfect. So that would be 5x squared minus 17x plus 12, all divided by x in the bracket of, now let's take out the GCF, combine x minus 2, then again we have x minus 2. So since these like terms are the same, since they are the same, we can write them as 1 or the power of 2. Okay, can just put them as raised to the power of 2. So eventually, finally, the expression 5x squared minus 17x plus 12 will be divided by x in the bracket of x minus 2 all squared. Now we are having a proper fraction with a repeated root. Okay, you can see it's with a repeated root. So we need to use the idea of that. If you haven't watched my video on partializing proper fraction with repeated roots, then I would suggest you check it out. Either you click on the link and just pop out, or you check out the description of the video. So let's find that of the linear term first. That will be a divided by x, then plus. Now for the repeated root, that will be b divided by what you are having inside, which is x minus 2. Then plus c divided by everything you are having outside, x minus 2 all squared. Perfect. Now, just like as we have been doing, let's multiply all two by, okay, let me just write it there. Let me reduce the font. We are multiplying all two by x in the bracket of x minus 2 all squared. So for the red color, the whole term cancels out, and left over is 5x squared minus 17x plus 12. For the green color, x cancels out x, and left over is x minus 2 all squared equals a multiplied by x minus 2 all squared plus, for the yellow color, x minus 2 reduces 1x minus 2, and left over is x times 1x minus 2. So we have b multiplied by x. Okay, let me set it as bx multiplied by x minus 2. Perfect. Now for the blue color, x minus 2 all squared cancels out, and left over is just cx plus cx. So that's it. Now let's solve for each and every of the constant a, b, and c. So first, let's determine the value of c, because that's one of the best one we can determine as the first one. Yes. So now, to determine the value of c, this has to be 0, this has to be 0. For that to be 0, we can set x minus 2, since they have it in common, to be equal to 0. And x has to be equal to 2. So plugging in x equals 2 in this whole equation, we have 5 multiplied by 2 squared minus 17 multiplied by 2 plus 12 equals a in a bracket of 2 minus 2 all squared plus b in a bracket of 2, then multiply by 2 minus 2, then plus c multiplied by 2. So 2 squared is 4, 5 times 4 is 20, minus 17 times 2, that's 34. Should that be 34? Yes, it should be 34. Plus 12 equals, this is 0, plus 0, plus 2c. Perfect. So now I'm actually running out of space. So let me get rid of this. Okay. Oh shit. I need to bring that back. I've actually miscut it. Let me do that back again. Perfect. So now let's add the 20 and 12. 20 plus 12 is 32 minus 34 equals to 2c. So dividing 2 by, 32 minus 34, that's negative 2 equals 2c. Dividing 2 by 2, then we eventually have c to be equals to 1. So c is equals to 1. So let me just put that here. C equals 1. Now, which other variable should we determine next? We can actually determine the value of a next. So now, to determine the value of a, we can set x to be equals to 0. In order to make this to be 0, similarly, there's x here. That can become 0. Should c be equals to 1 or negative 1? We said negative 2 equals to c. So c should be negative 1. Okay, solve for that. Negative 1. So we have 5x. Okay, let's just set x to be equal to 0. At x equals 0, we have 5 in the bracket of 0 squared minus 17 in the bracket of 0 plus 12 to be equals to a in the bracket of 0 minus 2 all squared plus b in the bracket of 0 in the bracket of x. It will be 0 minus 2, then close the bracket again, plus c multiplied by 0. So that will eventually be 0 minus 0 plus 12 equals negative 2 squared is 4. So we have 4a plus 0 plus 0. So eventually 12 will be equals to 4a. And dividing 2 by 4, a equals 3. So as c equals negative 1, a is equals to 3. Now that we have the value of a and c, we can determine the value of b by just plugging in a suitable value, but the one that will make things work best for us. So we said a is 3. So I would like to plug in 1 for x in order to determine the value of b. So at x equals 1, we have 5 in the bracket of 1 squared minus 17 in the bracket of 1 plus 12 equals a in the bracket of 1 minus 2 all squared plus b in the bracket of 1 multiplied by 1 minus 2 plus c multiplied by 1. And that will be 5 minus 17 plus 12 equals 1 minus 2 is minus 1, all squared is a, plus 1 minus 1 is minus 1, and 1 minus 2 is minus 1 times 1, that's the minus 1, times positive b, that's negative b. That's minus b plus c times 1, that's c. So that's what we have right now. So we can determine the value of b. So now, therefore, since this whole term will become 0, because 5 minus 17 plus 12 is 0, we have 0 to be equals to the value of a is 3 minus b, the value of b or c is minus 1. So therefore, if I bring this b to this side, this cancels each other, b equals 2. So that is the value of those constants respectively. Oops. This problem is actually a monster problem, but eventually we'll go to all these constants. Now we can write the whole answer, okay, the final answer. So this fraction, 5x squared minus 17x plus 12 divided by x cubed minus 4x squared plus 4x has been decomposed, split to 3 divided by x, I suppose, then plus 2 divided by x minus 2. Then this is negative. That will be, okay, let me write it so you can know how it works. Minus 1 divided by x minus 2 all squared, which becomes 3 divided by x plus 2 divided by x minus 2. Then minus 1 divided by x minus 2 all squared. So the next thing is just to associate the quotients. So final answer for the original problem will become this. That will be x plus 3 divided by x plus 2 divided by x minus 2, then minus 1 divided by x minus 2 all squared. And that will be our final answer. And that is it for this video. Thanks for watching. See you guys in the next video. If you haven't subscribed, do well to subscribe. Bye for now.